Brilliant. Okay, thanks everyone for joining this meeting. This is our first one in the East Anglia branch, so it'll be interesting, and hopefully it works, because it'll be an idea for the future. So thank you for joining. For the meeting today, we've got Mark Moore, who's going to give us a talk on the vision of farming. During the talk, I'm going to mute everyone. And then when Mark has finished, we'll ask for questions. But if I could just, you'll be muted until then. Save everybody trying to ask a question at one time. Would you be able to raise your hand, and I'll call out your name, and if you could then ask the question. So it's now over to Mark to do the presentation, and let's go from there.
Okay,
Thank you.
If someone can confirm they can see my screen. Is that okay?
We can see you, Mark.
Yep, fantastic. Okay. So welcome to rural Warwickshire, where I live. So this is a bit of a strange meeting for me in some respects. Normally I'm stood in front of you all giving a presentation. I can see some of you on the right-hand side of my screen here, so I'm going to try and keep you all awake. But we'll go through this, and I think the format is that we will ask questions at the end, and I'll do my best to try and answer them. So just a way of introducing myself, my name is Mark Moore. I work for AGCO, and in fact next week, the 2nd of July, will be my 30th anniversary of working for AGCO. Can you believe that? 30 years of working with the company. And most of that time it's been working in the area of technology, in particular trying to develop the application of technology and delivering that to not only farmers but also dealers as well. So that's what I'm going to try and sort of focus on to a certain extent, and also think about how this is going to develop into the future, in particularly related to the lessons learned or some of the personal experiences that I've had over the last 30 years. So okay. So I thought just a way of a history lesson, as it were. I'm sure some of you are familiar with this work from Rothamsted. But as an industry, we've been pretty successful. You can see the timeline along the bottom there from the 1800s up to today. And what I've tried to do is add in some milestones, as it were, where we've tried to introduce technology or new varieties or plant breeding, chemicals. And that has obviously given us a step up in terms of yield and our ability to produce food. But of course, the big question is what's next? I'm sure some of you have heard of this term farming 4.0. I'm not sure if we all know what it means, but certainly it's something that gets bandied about. But I think we should give ourselves a pat on the back here, because as an industry, we've done pretty well when you look at the way we've progressed and our ability to feed a growing population, which we all know is going to be around about 10 billion by 2050, which is not that far away. So there's a lot of people looking to us for some answers and the way we're going to get to the point where we can feed all these people, hence this term farming 4.0. So I'm going to give you my vision of farming 4.0. A little bit of history. This is some work that I did in 1985. So this is yield mapping. This is something I did my PhD in. This is before GPS, guys. So we had radio beacons in the corners of fields to position combines, which had a yield meter on. And you're all familiar with the ability to try and collect this data now and produce it, maps, and try and use it. That's just a picture of a, would you believe, a CRT screen. So that's the yield map that we produced in 1985. And it wasn't too far from where I'm sitting, actually. There was a field in Warwickshire. You can see all the yields along the bottom. and the various colours that we can see, representing the different yields across the field. In the following year, we also did some variable rate stuff as well. So we did some chemical treatments, and this one is just focusing on some of the variable rate N. I think probably in those days it was more about trying to prove the concept of the technology rather than actually trying to correct yield variations or increase yields at that moment in time. But obviously this was some very early work. And then in 1991, GPS became available. So a product called Differential Global Positioning Systems. I'm not sure if you guys remember this, but in the early days, the Americans used to scramble the signals. So we had to use a system called Differential GPS, which was a separate reference station that enabled us to correct the accuracy of the system down to about plus or minus 10 meters. Plus or minus 10 meters, that doesn't sound very accurate today, but that's pretty good back in the early 90s. With the development of GPS, Massey Ferguson went live with the yield mapping system, and we sold 5 systems in the UK, which I personally looked after. This combine was at Shuttleworth, where I did my PhD. In the sort of the center picture there at the bottom, that's the differential station that was set up in the corner of the field to position the combine within plus or minus 10 meters. And we generated the yield maps that you can see. It doesn't look very pretty there, but again, it was more about producing or generating some information about the accuracy of the system at that time. So we're coming up to date, 20 years on. It's a bit disappointing in my opinion. I mean, precision farming has been around for 30 years. And I think adoption rates are pretty low, in my honest opinion. I think when you think of some of the technology, it's been recognized as some of these things that can revolutionize the way we do things on the farm. But overall, a lot of people have been a little bit disappointed. And this is just a report from the EU. And the bit that I highlighted there in red was after, well, initial enthusiasm followed by a certain level of discouragement due to lack of support. And that's what I'm going to focus on to a certain extent through my presentation, is lack of support. And that then leads into the relatively low profitability obtained. And I'm not just saying this for the farmers, I'm saying it for the distribution, the dealers, and everybody else within the supply chain. So that's something that we need to keep in the back of our mind as we try and develop some of these technologies and delivering them to farmers. Some of the challenges I think that we're faced as an industry, I've tried to list down here. Certainly from my personal experience, systems integration is something that we've always struggled with as an industry. There's various reasons for that, but we are not good at delivering systems to end users. And I'm going to talk a little bit about that in the next slide, as it were. I think a lot of people work in silos, so we've got to break down those silos. But the requirement is to work across sectors to make sure technology solutions work and are supportable at farm level. And I'm an ag engineer, like I guess the rest of us on this call. And the one lesson that I've learned is that an ag engineer is a natural systems integrator. And that's what I'm going to keep repeating all the way through this presentation, is that we are the best systems integrators that the industry has at this moment in time. And that's an opportunity. The value proposition, obviously, if we can't get the system working, if the technology, and we're struggling to get it working on the farm, then the value proposition is somewhat hard to get at the same time. And again, this comes to the lack of profitability, not necessarily just for the farmer, but also the dealer as well. I know a lot of dealers that have had their fingers burnt, as it were, that have dabbled with this technology. sold it under the banner of plug and play, and struggled to then make any money from it. The integrated mechanization technology with agronomy, that's something else that we need to do. Coming back to the theme of systems integrators, we need to work with agronomists. I know a little bit about agronomy, but I'm not an expert. We have to work with somebody that understands the way farmers use technology and fertilizers and chemicals to grow crops. And then ultimately we can then demonstrate the value proposition and the solutions to the end farmer, end customer. Falling out of that, number 3 is education and training. If we're struggling to integrate the technology into a solution, we're struggling to understand the value of the technology, we haven't got a very good training program that we can then deliver to the industry. So a lack of agricultural systems knowledge within distribution to sell and support technology solutions. I think one of the good things about this is that we have lots of believers out there. There's a lot of people within the industry willing us to succeed. I think most people today accept that technology and data is part of their future, but there's a lot of help that these guys need to get it up and running. So I think one of the requirements is to provide the foundation to educate and train customers and the supply chain on technology, but they need to be built on solutions and the value proposition. And then finally, we're talking about the distribution and support. And I know a lot of people sort of home in on farmers and end users. Well, that's correct, but we also mustn't forget about the distribution and the support network. Good dealers are developing their own solutions. I know some in the UK that I guess through customer requirements are going out and developing their own solutions by becoming that systems integrator, as it were, and trying to piece all this together and help their customers at a local level. And as I say, to deliver opportunities for the dealers to grow their businesses, because they need to make money as well, by showing value of the technology products and services to their customers. That's what I'm going to focus on through this presentation now and relate that to Farming 4.0. So systems integration. There are good systems out there that I would perhaps call vertically integrated systems or product systems. There's a good example, the Ferguson system, AutoGuide. And there are lots of others out there, but I think these types of vertically integrated systems, they tend to focus on one element of a system. They normally supplied and supported by one organization. So it helps that vertical integration. And as a consequences of this, the value proposition is relatively easy to obtain. So we've got no real issues with a lot of these sort of vertically integrated systems, and there's lots of success stories out there. However, if we flip over the other side of the coin, we've also got horizontally integrated systems, and this is where we tend to struggle a little. So some examples: precision farming, controlled traffic farming, conservation ag. I'm not saying these don't work. What I'm saying is you have to work at it. They're not that difficult, they're not that easy for a farmer or a dealer to get up and running. You've got to be pretty dedicated. And I know farmers particularly, or some farmers, that will sit in front of a PC all night and trying to reformat data files so they can get their application map from a piece of software and into their tractor to go out and spread fertilizer in the morning. So these tend to focus on farming practices rather than individual technologies, but they can be built or pieced together from vertically integrated technologies. And that's something that we can use to do that. But the key point is that they are from multiple sectors and groups who create the system. And these multiple sectors and groups, they need to talk to one another, and they need to get these things up and running. And as I said, we're ag engineers, we are good systems integrators. We can try and bring these guys together and get them up and running in that respect. An example, we had the pleasure to work in Africa for the last 7 years since 2012. This is Zambia, by the way. So we have a model farm in Zambia, and this is the sort of the life cycle of growing maize down there. So we plant in October, we grow through the growing season, through January, February, March. Harvest is in April, and we start to evaluate our systems in May after harvest. What I'm trying to demonstrate here is that there's lots of different things going on throughout this season. So in October, we start planning. That normally involves a piece of software. So we want the software to produce an application plan, which we then want to take to the planter, put inside the planter, and start planting seed. Maybe with a herbicide, maybe with some chemicals, so we need some input from the agronomist as well. Similarly, we need to think about soil fertility, so maybe there's some nutrients that we need to do, maybe there's some subsoiling, all these things that need to come together. So the machinery guys need to bring some tillage equipment to the table along with the software companies. Then you go into the growing system, so the agrochemical companies need to be part of this solution. Same with the fertilizer companies. We want to bring in weather data. So someone has got to produce a weather station or have access to weather data. That's another source of information that the farmer has to deal with. And then ultimately in April, we end up harvesting. And hopefully we get something that we want to put into a silo and ultimately sell at the end of the day. And at every stage, we're going to get some data, some information from these particular systems. And at the end of the process, we want to evaluate and produce reports that we can try and start to develop systems for the following season. The farmer primarily does all this himself. He doesn't develop the technology, but he brings all these bits and pieces together. Now, the interesting thing as an ag engineer is that we actually touch every part of this system, this process. So if we take agrochemicals, we make sprayers. We are into application technology and things like that. But we're not agronomists and we don't sell chemicals. So we have to work with agronomists and we have to work with the chemical guys to develop a package or a system that can do variable rate or spot spray chemicals or whatever it might be. Now, if we go to fertilizer, again, we touch that system, but the chemical guys might not. Now we're working with a different group of people, maybe a fertilizer company. So I firmly believe that we have an opportunity here to try and smooth out the bumps, as it were, and bring this together on behalf of the farmer. Systems integration, this plug and play, ensuring compatibility with technology, with different technologies exists in a real situation. And that's just some of the things that we could do. We can bring in some the software companies together. We can make sure that the software flows into the controllers, into the sprayer. We can make sure that the feedback loop is there in terms of as applied, and we can make sure that this thing flows seamlessly in this instance. And I can produce another one for fertilizer and things like that. Some of you might be familiar with this work that was supported by AGCO in the late 90s. This was some work that was done at Silso. Nothing wrong with the technology. The technology worked, but we need to deliver the value proposition alongside that. We need to demonstrate the value that it does deliver. I think probably in the late 90s, piecing this technology together, although we did it as a research program, it was perhaps beyond the dealers and the farmers at the time. But I think today this is very achievable, provided we can create these plug and play systems. We know that the value proposition can be obtained. If you read the wheat growth guide, then a lot of the information that you see on the flow diagram here is still appropriate. The ability to manage tiller densities and things like that through the use of nitrogen fertilizer is still current thinking, relating that to canopy management. So there's lots of different elements out there today that we provide us with an opportunity to bring this together and make our life a little easier. So it works because we've developed a systems integration. We know the value proposition, and now we got the platform for a great education and training program. And this is something that we're trying to do as a company. This is AGCO, by the way, is to develop our training to include agronomic knowledge. So we don't just focus on the nuts and bolts now. So perhaps the boxes in red, the internal technical training boxes and the product training boxes up there in red, are sort of our comfort zone, the things that we've perhaps done historically. But as a company, we're trying to evolve that now and bring in some of the knowledge on systems integration and the value proposition and develop the blue boxes. So we're talking more about solutions now. We're teaching about solutions on crop establishment, protection, nutrition, harvesting, record keeping. These are some of the things that as a company that we're trying to bring together and show the farmers and the dealers that, you know, this thing is achievable on your farm and you can get it up and running. Again, another slide just focusing on the distribution and support. This is again something that as an industry we can sort of try and foster collaboration across these different sectors and companies. The farmer up there in the top right, he has a network of what I call trusted advisors. He trusts his family. The vet, the neighbours, the agronomists are all valued, trusted advisors in my opinion, and they have a lot of contact with farmers. The guys in the middle, I think, are probably in the middle there. They have some contact with farmers. Maybe they're not always trusted as much as the agronomists or whatever, but that's quite often the case because they're trying to sell something. No, nothing wrong with that. We all got to sell stuff at the end of the day. But if we can combine it with some value proposition, maybe there's an opportunity to move a bit more closer to the farmer. You've got another layer in there, the government, the media, the universities, they have a part to play. And then you've got the global players, the CNHs, the John Deeres, the AGCOs, the Yaras, the Syngentas, you know who they all are. Their challenge is how to access the farmer. And the way they do it is through this network, this supply chain. So there's a role there to try and sort of create these this collaboration to ensure that the thing works and it delivers the value that the farmer is expecting at the end of the day. There are some good examples. In Africa, you've got one example here. This is in Ethiopia. They're setting up sort of what I call one-stop shops. So this is like a supermarket, I guess you could say, for an agricultural supplier, where they don't just sell the machines, they sell everything, including agronomy, finance, farm business. You can get your seed, your fertilizer from one place. And another one over there in Europe, BayWa. I don't know if anybody knows, is aware of BayWa in Germany. But they do exactly this. So they bring the elements of the system together, as it were, and help the system in terms of its usability on the farm. They assist with that process. So we're moving in that direction, guys. I know some dealers in the UK are thinking about sort of hiring agronomists to help sell the sprayers or the fertilizer spreaders or the tillage equipment. So there's lots of elements happening and to get us down that way. But what about the future? So I don't know if I think a good thing to do is to look at sort of what's happening in consumer tech. I think you've all heard about the Internet of Things. Well, I think over time we're going to sort of migrate to what's called the intelligent of things. This is the sort of the next level where things are sort of done for you, that they learn as you go forward. Switching on your lights in your house, for example. I think there's a lot of good things that are happening already. You can get these things from Amazon and whatever, and you can link them up to your Wi-Fi, and they can turn on your music and things like that. But what about irrigation systems, for example? If an irrigation system is linked to the internet, it's aware of what weather is coming around the corner. Maybe it can make the decisions on when to apply water or not, as the case may be. So in other words, it's becoming intelligent by looking at the information that's available on the internet and making decisions for you to help with the management processes that are going on. So in the case of an irrigator, it turns on and off automatically. You just leave it alone and allow it to get on with it. Another, I think, thing that's going to happen and revolutionize our industry is 5G communication. We're not going to stop this, guys. It's whether we like it or not. It will enable us to do a lot more in the future in terms of managing data and systems out there. So let's harness it and let's use it to our ability. And I've got something in there called smart agriculture in the left box. Well, as I say, I think that will certainly help the way that we can do it. Now, I haven't got all the answers, guys. But all I'm saying here is you've got a technology that will really enable us to communicate certain things much more efficiently than we have done previously. And I am aware that in ag, we are working in some remote locations. It's not always possible to get a reliable 5G connection, but there's nothing to stop you collecting in data on a machine and then providing that feedback once you get back into a Wi-Fi or communication zone. So watch consumer technology, because that will enable us to learn about some of the things that we can do moving forward. So there's just some examples. Automated farming equipment. We've already got things like the RRN sensor, which is a sort of a smart farming system in its own right. But again, we could link that to the net, and we could perhaps relate that to some models to manipulate nitrogen fertilizer accordingly. So all this is possible. Precision ag, we've talked about. Again, maybe you can have drones flying up and down and they are managing and communicating with machines in the field in real time. And connected micro weather stations, again, coming back to the idea of having irrigation systems that can make decisions based on what weather is forecast or just coming out from that day. Controlled traffic farming. This is Brazil. This is not how to do it, by the way, guys. This is a tractor applying lime, and I took this picture, and you can see that the guy is running over the sugarcane. Sugarcane is grown under sort of a 4 or 5 year cycle, and the last thing you want to do is, having cut the cane, is then run over it with a machine, because you stunt the growth and you lose about 40% of your sugar in the subsequent crops. So things that are happening out there is controlled traffic farming. This is the solution. So all the wheelings now are in between the rows. This is becoming quite common practice now in some parts of the world. So controlled traffic farming is becoming part of where we're doing. So the maps where to drive are sent to the machine. They're stored at a central office. So the first thing that the driver does is he chooses the field. He then drives or switches on the auto guide system, and the tractor drives in between the rows. Well, in the future, maybe the system automatically recognizes what field it's in, and it just selects the field for him and takes over control of the tractor. So that means we're not too far away from automation, so robotics, leader follower tractors. These have been around for a while. I don't know anybody that's using them. I think they're probably something that we applied for a gold medal at Agritechnica, for example. This is sort of proof of concept stuff. There are safety issues around there that we need to work around. Again, another opportunity for an ag engineer. This is coming, but ultimately this is what it's going to lead to: full autonomous intelligent machines. So you've got 5G, you've got the GPS, you've got all the technology now to link these things to the cloud, to make the decisions for you. So we're not that far away from this, guys. There's lots of things that we can do here to bring this together and develop it into a system where you bring the data, you bring the technology, you bring the machinery together. And ultimately this thing called precision farming, whatever you want to call it now, farming 4.0, becomes much easier for the farmer to implement on his farm or her farm. Another one around here, I know Harper Adams are doing some work in this area. You've heard about the hands-free hectare, for example, I'm sure. Well, let's think about how we're going to bring this technology, that concept to farming. There's not a lot of products out there that farmers can buy today, although the proof of concept is gathering pace. There's some things out there that we can start to think about. Crop protection, this is something from Bayer I discovered on their farm in Germany. These devices, they automatically detect levels of pests in the field. So the flies or whatever it is that they're trying to detect drop into the yellow container. There's a camera above it. The system then sends up this information automatically into the cloud. And then we can sort of predict when things are when we need to spray to be proactive rather than reactive. I think as an industry, we need to be more aware of environmental things. So maybe there'll be compliance issues here where farmers are not allowed to spray unless they are proving that they are being proactive. In other words, there is an urgent need to go out there and apply a chemical based on an infestation level that's been detected in this yellow container. So there's a lot of this out there at the moment, and if this can be linked to weather patterns and information as well, there's things on fungicides and things like that we can be a bit more proactive on as such like. Again, 5G will enable all this to happen much more efficiently. Soil sensors, you've got an organic matter map there. It's produced from this sensor. AGCO acquired a company called Precision Planting, which developed something called the Smart Firmer. It uses technology to detect how much organic matter. It basically measures the color of the soil and then relates that to soil organic matter. Another layer of information that we can now use to try and help the farmer be more efficient in terms of how we can be more efficient at growing crops. There's lots of other things out there that are available. We can detect soil moisture as well as organic matter. Levels of trash in soil now, these types of sensors can do. So there's a lot of application. So again, it's trying to develop the value application, the value proposition on top of this stuff as well. NVDI sensors, we talked about this earlier, lots out there, not always integrated into what the farmer wants to do. They tend to be these vertically integrated systems. I know AGCO, the technical support team, have some problems speaking to some of these guys because they'll produce some information which the farmer can't get into his Massey tractor to control his end sensor or whatever it might be. So standards are sort of some of the things that we need to work on and think about in the future. But all this stuff is in the pipeline, guys. Another slide that I pinched from Bayer is some vision of what the 5G farming has looked like. So all these elements of the system that I have shown you in this presentation will be linked together by this FarmG network and deliver much more data which we need to convert into value for the farmer. I often tell people we can soon fill a computer up with data, guys. Filling a computer up with data is not a problem. It's trying to figure out what to do with that data and where the value sits. That's where we need to get better. So in summary, guys, for us, we got a bright future. So
I didn't catch that. Could you try again?
So I think we need to be a little more aware of some of the challenges. And one of the big challenges that I've tried to highlight is that technology is not a problem. We've had it for 30 years. I've done this for 30 years, and a lot of farmers still struggle with yield maps, particularly on how to use them. So, and I can take it to some farmers that have got 30 years of yield maps in their drawers. And I don't know if they've got always the value that they initially wanted from them. But anyway, we are where we are. We have a good future, guys. So don't be shy. The challenge is delivering usable technology to the farmer. It's about bringing the different elements together, not necessarily developing new technology all the time, but taking what you've got on the kitchen table and figuring out how you can make it more usable to the farmer. So industry collaboration, in my opinion, delivers this. So I think that's one of the things that as an ag engineer, we can facilitate. I told you at the start, we touch many parts of what the farmer does, if not all the parts. Everything requires engineering at some level. So there's the ability for us to ask all the awkward questions about the industry, about how this is going to work, how is it going to bring it together, can we support the integration of it, all those things. So if we can get to that level, it will reduce the current support burden, not just only for us, but the agronomists, for the dealer, but most importantly, the farmer is happy because he pushes the button and it works. And that's all the farmer wants. All he wants to do is push a button and drive up the field. So if we can get it working, it allows the progressive companies, the dealers, to develop a sustainable business from localizing this technology. And that bit on the end there, localizing technology, that's 2 words, but that's an enormous task because there's no farming manual. You can't take technology and apply it in the UK in the same way that you apply it in Germany, because farming practices are different in Germany compared to UK. The soils are different, the topography is different, the climates are different, the pests and the disease are different. So there has to be an element of localizing technology. There's no manual that says, if I take this off the shelf and I do ABC, I get X, Y, Z. That doesn't exist. That's an opportunity for us guys, because if it was that easy, people would be doing it. So they need our help to localize this technology. So we need more systems thinking, and I'm going to bang on about this until I get it right. But we need this plug and play products and service, deliver plug and play products and services to these farmers. And as I said, agriculture engineers are natural systems integrators. A good example of joined up thinking. New Zealand. I don't know if anybody you've come across Agritech New Zealand. This is something that I think we should aspire to. So I'm not saying they've got all the answers, but they've certainly created the platform. The New Zealand government has created the platform to facilitate this uptake of technology and position themselves as a technology hub for New Zealand. So Agritech New Zealand, as I say, this is a quote, is an association of organizations and individuals. It's like a club. Maybe it's a bit like the Institute of Agri-Engineers, I don't know. To come together to lead a program of work, taking key role in growing our industry's capability to maximize opportunities, enable agritech, and address any of the challenges. We know what the challenges are. I've sort of tried to outline them to you. And Agritech New Zealand have created an action plan last year. You should go onto this website, by the guys, and have a look at it. Promote horticultural robotics. There's that word again, robotics. So they're trying to take things like the hands-free hectare that we see at Harper Adams and commercialize it. So there's a lot more support from the commercial organizations to bring on this robotics technology and try and commercialize it. They host the Farm 2050 nutrient initiative is part of this Agritech New Zealand. So there's a proving goal. There's almost like a model farm, I guess you could say, where they come together and they see if this works in a practical farming environment. And perhaps more importantly, there's a creation of a specialist Agritech venture capital fund. So it's not just pushing money out of the door into the laps of the researchers and asking them to develop the technology. There's a fund that specifically set aside for venture capital. So although this is supported by the New Zealand government, the venture capitalists are part of this organization as well, because they're looking to invest in technology. So it's about trying to de-risk some of this for the venture capitalists. So look at that. I'm quite excited by this. I wish our government could do something similar. We have Agritech over here. Don't get me started on it because, okay, to be fair, there are some differences between New Zealand and the UK. The New Zealand government is much more streamlined, for example, than the UK government. So I know you're recording this, so we need to be careful what I say or don't, as the case might be. And then finally, have a read of this. This is a good little paper written by the Harvard Business Review, How Smart Connected Products Are Transforming Competition. There is some ag elements in this paper, but it's not just related to agriculture. It brings in other industries as well. But it gets you thinking about what they call systems of the systems, this horizontally integrated technology and how we can bring all this together. And as I said to you, all a farmer wants to do is push a button and work. And that's not an unreasonable expectation, is it, guys? If the farmer buys something, at least he expects it to work. So let's work on behalf of the industry. Let's bring people together. Let's get things up and running. And then we got the ability to make a real difference, and maybe we can simplify this farming 4.0 for the future. So I will finish there, and I'm not quite sure what to do. Do I hand you back to you, David, or how is this going to work now? Are you all awake, or did you all fall asleep in that? I can't see you, so I'm not sure if you're sleeping or not.
Sorry about that. Yes, thank you so much, Mark, for that really interesting talk. I like the idea that ag engineers are the natural systems integrators for the future, and that we need to develop a one-stop solution. I like the idea about needing to work more closely with the farmer, the end user, and bring them all together, so that one of your slides, I think ag engineers were in the bottom left-hand corner, the farmers the top right. We obviously need the ag engineers up there as one of the close friends of the farmer. So that's going to be interesting. And yes, we can get loads of data through 5G and GPS. And I guess the idea is we do need to simplify and make a real difference. Although there's probably many farmers on the phone at the moment, or ag engineers, who would either even have 3G at the moment, particularly in places like Norfolk. So what I'm going to ask is, if anyone's got a question, if they could raise their hand. I think Clive Morse, you've raised your hand. And if you could then ask your question. Yes, so Clive, have you got a question?
Yes, thank you, Mark. Most informative. What I've taken away from that is a lot of the technologies are here. We've got them. but they're not talking to each other. Have you thought, and this is not an easy task, it's a big ask, of in the same way that Mercedes, Daimler, BMW, Fiat, Jaguar Land Rover all got together to develop a thing called OBD and OBD2, a common language for diagnostics, if AGCO, John Deere, Fendt, Bayer, the agronomists started trying to work to certainly a European standard, maybe a global standard for data?
Yes, so actually we have got a standard. Some of you have probably heard of a term called ISOBUS. So as a group of global machinery people, I guess I would describe us, we all comply to that standard. So the information that we collect or pass out to various systems comply to that standard. So that standard originally developed around the DIN 9684 standard. A guy called Dr. Auenhammer from Weinsteffen in Germany was sort of one of the pioneers of this. That evolved into 11783, so ISO 11783, and then now it's more commonly known as ISOBUS. And I think as a group of global machinery players, we are quite happy that that standard exists and it works. But the problem that we have is that it comes back to these two words, localizing technology. So whilst we have a global standard, the small agronomic company or the small software company in the UK and the small software company in Denmark and then Spain and Germany, they're not necessarily complying to these standards. It takes effort and resources from their behalf to work with those standards. So that's one of the challenges that we got is our life is not simple because of this need to localize the technology. BMW, the Fords of the world, the global manufacturers, okay, they might sell different models around the world, but all intents and purposes, they're not dealing with a biological system that we are as ag engineers. So we've got a sort of a different thing that we have to deal with called this localization, this ability to control and develop specific solutions, or in terms of using information for, I was going to say every farmer, but probably for every field as much as every farmer as well. So we have a very complicated life compared to BMW.
Oh yeah, I know that. When people say agricultural engineering, what's that? Mechanical engineering plus, including soil physics.
Yes, but it's an opportunity, guys. I mean, this is why people need our help, because life is so complicated and dynamic for the farmer. There's no right or wrong answer in many instances. It's a case of trying to accommodate things that season. Here in Warwickshire, we had zero rain in April, May, and now we've had a deluge. So, BMW don't have to try and deal with that. We do as engineers.
Oh yeah, know that one.
Right, thanks, Clive. I don't have any more hands up, so we'll try this out to see if there are any other questions. If you can just say your name beforehand, and we'll go from there. So, any further questions?
Paul Baskerville here.
Go ahead, Paul.
Hi. Last meeting we had in our branch in East Anglia was a small robot company. Are you familiar with them, and do you think they're on the right track?
Sorry, I need to turn my volume up. I missed that.
Okay. It's Paul Baskerville.
Yeah, got your name, Paul. Sorry, Paul. Yeah.
All right. And in our last meeting, real meeting at class, we had a presentation by the small robot company who are based down in Salisbury. Have you heard of that company?
I have, yes.
Do you think they're going in the right direction?
Yes and no. I mean, the UK has some fantastic small SMEs, these small dynamic companies that are very fast on their feet, very innovative, and can develop the technology. Quite often, though, these small SMEs are not good at distribution and support, the things that we are good at. So we actually, the large OEMs like AGCO are not necessarily always fast on our feet. But if we can combine the strengths of a small SME with the strengths of a large OEM, you can bring the technology to the market much easier. So this is why it's not always about the technology. It's about putting the technology into the hands of the farmer and then being there when he wants some support when it breaks. So that's, I think, the strength that we can build within this sort of collaboration through things like AgriTech. Certainly that's what the intention is with the New Zealand organisation, is to bring these various complementary organisations together and make sure that we exploit their strengths and deliver something on behalf of the industry, in this case the farmer. Because ultimately the small guys, they want to generate volume sales. They don't necessarily want to be restricted to 50 sales a year. They want to grow their business and ultimately evolve into a company of a sizable value that the UK government wants to pay taxes. I mean, that's basically it. They want to employ people and those people to pay their taxes. So we all have our part to play here. So I'm quite excited by it. So I would love to be talking to more of these SMEs and making sure that their technology either works with our machines, or we can open up our distribution network to these guys to sell these complementary products en masse so they can grow their volume sales. And everybody wins. And the most important winner is actually the farmer, because he buys something that works.
Yeah, thank you.
Thanks, Paul. Any further questions? No. Okay, then. Well, Mark, thank you so much for that very interesting talk. It's been great. As I said, this was the first time that we've done this sort of talk in the East Anglia branch. So really appreciate it. It's a really interesting format. Thank you for an enlightening talk. So thank you, Mark.
Thank you, guys. As I say, keep watching. We're needed. So don't retire just yet, okay?
Okay. Congratulations
See
on
you
your
guys.
30 years.
Yeah, take care.
Bye.
All right.